In today's video, we're going to talk about how to model one-step equations. This is the first video in Unit 4, so our new color for Unit 4 is blue. Alright, so we have a picture here. We've got two rectangles and two squares. These are called algebra tiles, and they represent variables and constants in an equation. Typically, a shaded in x will be a negative x. A shaded in 1 will represent a negative 1. Clear or open will represent x, and a open square will represent the number 1. Sometimes these algebra tiles will be labeled and sometimes they won't. It just depends on the problem, so it's always important to check the key when you have an algebra tiles problem. In the case of this video, this is going to serve as our key. Alright, I went ahead and labeled them in your notes just because I wasn't sure how well it was going to photocopy, so that should help us out as well. So if I take a look at this first example, the bar x represents 1x, and then I have 1, 2, 3, 4, 5 positive units, so this would be x plus 5. This division line right here, or it's not really a division line, but this line right here that divides our mat into the left side and the right side represents an equal sign, and that equals. And then on the right side of the equation we have 1, 2, 3, 4, 5 units, so x plus 5 equals 5 would be the way you would set up that equation. Alright, the next one, I have 1 positive x, so x, and then I have 2 negatives, and actually this should probably be a negative x since it's shaded in here. So negative x minus 2 units, so 2 negative units, is equal to 1, 2, 3, 4, 5 positive units. Okay. Next example, I have 1, 2, 3 x's, and then I have a positive 1, so plus 1. And here's a different form of a mat. You could see this as well. Equals, and then on the other side, I have 1, 2, 3, 4, 5, 6, 7 units. So again, we're really just looking at the picture. We're matching up the pieces. We're counting the x's, counting the units, and then writing it down. Next example, I have 2 x's, so I would write 2x. A positive 1 plus 1. Bar equals 1, 2, 3, 4, 5. Last example for how to set up, so going from model to equation, I have 3 x's minus 2 units, 2 units subtracting, equals, and then on this side I have 4 positive units, positive 4. Right now we're going to do a little bit of setting up and solving together. So remember, these are your algebra tiles. Okay, this is a negative x, this is a negative 1, positive x, positive 1. We're going to draw and solve. So my first example, I have 3x equals negative 6. So I'm going to draw 3 x rectangles. There's 1, there's 2, and there's 3. And they are not shaded in because they're positive. And then on the other side, I'm going to draw negative 6. And then I want to think about if 3x is equal to negative 6, I'm going to group on this side into 3 separate groups with 1 x in each. So I'm going to put, here's group 1, here's group 2, here's group 3, and they all have 1 x inside. And I need to divide the other side into 3 groups. So there are going to be 2 negative x's inside each group. There's 1 group, there's 2 groups, and there's 3 groups. So we made 3 groups on each side, and 1 group was equal to a negative 2. So my answer to this equation would be x equals negative 2. So there are 2 negative units inside each group. I've got 3 groups on this side and 3 groups on this side. I made 3 groups over here, I made 3 groups over here. Whatever I do on the left, I also have to do on the right. Alright, the next one, I have x plus 2 equals 4. So I'm going to draw an x. And then I'm going to draw a positive 2. And on this side I have positive 4. Okay. I can't just make groups anymore because I have to have the same thing inside each group. I can't make this into different groups. It's not possible. So I want to figure out how I can get the x by itself. I would really like to get rid of these two pesky units, and I can do that by creating some zero pairs. So I can draw in two negatives on this side to get rid of them. Remember, we talked about canceling out zero pairs. So that means these two are going to cancel out, and these two are going to cancel out. But if I draw two negative ones on this side, in order to keep this scale balanced, I'm going to have to draw two negatives on this side. Whatever I do to one side, I do to the other. So on this side, I divided it into three groups, and this side, I divided into three groups. This side, I drew two negatives. This side, I'm going to draw two negatives. They have to be the same on both sides. Cancel the zero pairs over here. And I have one x left, and I have a positive 2 left. So my answer is going to be x equals 2. Last example, I have an x minus 3. So I'm going to draw an x, and then I'm going to draw 3 negatives. And then on the other side, I would like to draw 5, positive. I would really like to get rid of these 3 negatives. I want to see just that x by itself. So I can do that by drawing 3 positives. Whatever I do on this side, I need to do on this side. So I'm going to draw 3 positives over here. And then I'm going to go cancel any zero pairs. These two will cancel, these two will cancel, these two will cancel. I'm left with x by itself. No zero pairs to cancel over here because everything is open. There's nothing shaded, so I can't cancel out. So I'm left with 1x is equal to 1, 2, 3, 4, 5, 6, 7, 8 on this side.